All right, so first lesson of the new unit. So those coming from grade 10, this is a brand new concept from anything you have done before. All right, up until this point, some of it may have been review, but this is brand new. So with any brand new concept, it's best practice. Let's start with some definitions, okay? Our focus is on periodic functions with the overall goal of discussing sinusoidal functions. And sinusoidal functions is a type of periodic function, okay? So what does it even mean to be periodic? Well, and a function. A function that produces a graph that has regular repeating pattern of x and y values is called a periodic function, right? So if we just look at that really quickly, all right, what it means by repeating x's and y's. If you think about a graph, right, you have x-axis here and you have your y-axis up here. If you hit a point on the y, right, well, I'd want to see that same point on the y happening at regular intervals. So if this spacing here is like, let's say 1 on the x, I want that spacing to be 1 each time, okay? So your y's are repeating at regular x intervals. That's what that statement is saying, okay? Just give a visual to it. So we have two more definitions here. One cycle of a periodic function is one complete pattern. So another periodic function that we all humans have to deal with is we have to breathe, right? So if you think about when you breathe, your lungs, I'm going to do a brutal job here, but your lungs, they will expand out as you take a breath in, so your lungs will expand and get really big, and then you will breathe out and they will go back in to once again take your breath and breathe in again, okay? So the cycle repeats itself. So the cycle is you breathing in, so your lungs expanding, and breathing out, lungs contracting, right? That is one cycle. That is one complete pattern. The amplitude, this is a word that we will be using a lot, and we are going to have to be calculated as. The amplitude is half the difference between the maximum value and its minimum value, all right? We'll go into more detail, so I'll just give you simply the formula right now, but the way you calculate the maximum, all right, so the amplitude, is its max minus the min, okay, divided by 2. And that is equal to your amplitude. And we typically donate amplitude as the letter A. Okay, so we give it A. That's for amplitude. The period of a function is the horizontal length of one cycle. Horizontal length, or a really common one when we start doing word problems, is like the time it takes. Like it could be in word problems or time. It could be, as it says, distance, like horizontal length, or like distance, right? So let's compare it to cycle, right? So using my analogy of breathing, a cycle was you taking a breath in, your lungs expanding, and breathing out, right? As your lungs go out and back in, that's a cycle. A period is similar to a cycle, but it's more about how long does that cycle take, right? That's what it means by one cycle. So, staying with this analogy, you breathing in and breathing out, that cycle will never change. Your lungs are going to go out and come back in. However, let's say, you're sitting at your desk. Well, your breathing rate isn't so fast, right? Like, you might be taking 2 breaths every 5 seconds or so, right? Like, you're not breathing very fast. But let's say you go for a jog, right? Well, now your breathing is going a lot faster. Your lungs are still expanding and coming back in. You're not changing the cycle, but you're changing how fast the cycle happens. And that's what period is, okay? So it's more talking about like how long or how far or like does it take you to do one cycle. And then the last terminology that we want to cover here is the equation of the axis. Think of it as similar to the quadratic unit where we had the equation on the axis of symmetry, right? The equation of the axis is the horizontal line that cuts halfway between your maximum and minimum values. So you calculate it very similar to your amplitude, with the key difference, as I write it out here, being the plus in between them, okay? So it's max plus min over 2. And that's what gives you your equation of your axis. I'm just going to say axis. And we usually give this the letter C, okay? All right, so this picture right here, this is putting all of those those terms onto just a nice picture for us, so we can see an example of a periodic function and where you would find all of these definitions. So let's start with the first one here, the cycle. Well, remember, a cycle is one complete pattern. So if we look at this graph here, try and identify the pattern. Well, you can see you have this sharp edge right here, okay? So, and we have two rounded edges here, right? In proper terminology communication, this is what we call a trough. This is what we call a peak, okay? So we have a rounded trough and a sharp trough. Well, that one's highlighted in orange, but notice how you can see you have a rounded trough, a rounded peak, and once again you have this sharp trough right here. Well, there's your same pattern being repeated. So this is another example. This distance here to here, this pattern is one cycle again also. So it's just one complete repeating of the pattern. Well, the period, notice the arrowheads right here, is the actual distance. It's how far you are from one to the other, okay? So in this case right here, if this is 6 and this is 16 as it says, well, your period is 16 minus 6, or 10. It took you 10 spaces to start your cycle again. That's what the period is. The maximum value, similar to quadratics, it's pointing to the highest point on your graph. And likewise, your minimum pointing to the lowest point, all right? And when I say point, it's talking about specifically these values here, the y values, right? What is the highest y and the lowest y? Well, the amplitude is halfway between the max. You also have that same amplitude going right here. And then notice you have this line right here, this black line with an arrowhead on it. Well, that is your axis. It's halfway between your max and your min. And another way to think of the amplitude is the distance from your axis to your max, or vice versa, your axis to your min, okay? So the amplitude is always touching the axes and going up to either the max or the min. So let's look at example 1 here. Determine whether each function is periodic. If it is, state the period and the amplitude. So if something is periodic, all right, what we need a repeating pattern. And in order for it to be repeating, we need the same y's over across as we move across. As we move across, across the x's. All right, so let's look at this first example here. Well, in order for it to be repeating, just pick a y value and be like, okay, well, I'm going to choose this -1 right here, all right? And that -1 is occurring at a peak. So let's look at all our other peaks. Well, here's another peak, 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 peak. But notice that the next one over happens at a value of 0. the next one over that happens at a value of 1. So your y's, you need the same y's in order for it to be periodic. Well, this is not periodic. You do not have the same y occurring as you move across your x's. So because it's not periodic, we don't have to state the period or amplitude. You can't. All right, so let's look at this. So again, easiest points to identify are your troughs or your peaks. So let's just pick this one right here. Well, there we have the highest point. We're at the highest point of 4. So let's find where that happens again. All right, well, that happens right here. So in order for that, we had to move over 4 units, right, to find that next point. Well, I can see that I have that same point once again over here. I had to move 4 units. So because I'm getting the same y value as I move across the same amount of x's, this is periodic, right? And you can do that for any of the other points. You can see that you have this kind of like halfway peak right here. And that happens again. That happens also over 4 units. So the y's are repeating at set intervals. So if you were to say, what is the period? Well, I've already kind of answered it for you. The period is right here. It's how long do you have to travel to get to the start of a next cycle. And again, cycle, this right here, is 1 cycle. So how long did it take you to travel 1 cycle? Well, the period equals 4 units. The amplitude, the second thing we're trying to calculate, the amplitude, remember, is your max minus your min, dividing that by 2. So let's look at our graph and find what your highest value is. Well, that is 4, so it's 4 right here. That's your max. And the lowest value is right here. That's your min. And that is occurring at a value of 0. So 4 minus 0 over 2 gives you 2. So our amplitude has a value of 2 units. We don't know what it is. There's been no defining what our axes are. So it's just units. Okay, let's look at our next problem. And this is a very short lesson. Really, the goal for this lesson is just you understanding the terminologies that are used when we describe periodic functions, and with the goal of eventually relating that to trigonometric functions, sinusoidal functions. Example 2. The graph shows the predicted height of water at Hopewell Cape, New Brunswick, during high and low tides for the first 7 days of May 2007, beginning at midnight on May 1st. Determine whether the predicted height of water at Hopewell Cape is a periodic function. Justify your decision. So remember, we are looking for the same y values to occur over the same x intervals for it to be periodic. So choose a value that is easy to find. Like, you're not going to choose a value right here and be like, oh, okay, that happens. You might be thinking it happening here, but remember, it goes up and down. So that would not be the next pattern, because you would need this to be going up as well for it to be identical to the first dot. So choose your peaks or your troughs. So your peak is right here. Okay, this is not at the same y value, so it's not the same peak. But here is the next one. Here is the next one. Next one. And notice how just visually on the graph, we are traveling 2 squares, right? And you can see there's another 2 squares that we have traveled. So these points, these y values, are happening across the same number of x intervals. So you can say this graph is periodic. So yes, it is periodic. Therefore, periodic. And it says to justify. And that's because y values are justification. Let's just make it very clear so you have it in your notes. Justification. Y values are repeating over the same x intervals, okay? And that word I'm using, interval, all right, think of it as like distance, right, distance. So part B says, estimate the maximum value and the minimum value of the function. What does the maximum value and minimum value represent? So let's look at this graph, right? And it is an estimate because we're not going to be able to get an exact number here. So those red dots, I've actually already identified the highest point, right? Like you can see those red is higher than that purple dot I've drawn. So if you were to just kind of look over here, because the max, remember, is a y value back from our quadratics unit, you're looking for what is this value right here. I mean, it's an estimate. We're not going to get exact, right? So how far, like what do each of these lines represent? Well, if we're traveling from 7.5 to 10, that means this right here, right? 10 minus 7.5, that's a difference of what, 2.5? So that means if we want to cut that in half, that means we are going 1.25 every single one of these dashes, right? So this would be like 6.25. This right here would be, that's 8.75. And going one up, that would be 11.25. So we're kind of, and if we go one more to the very top of our graph here, add another 1.25, that's 12.5. So it looks like we're kind of halfway between 12.5 and 11.5. So if we were to find what this distance is here, right? Well, the max, actually, yeah, I'll draw my graph up here. That value, that max, looks like it's about halfway between your two values. So finding halfway point is 12.5 minus 11.25, dividing that by 2. And my mental math is not great today, so I'm going to use my calculator. 11.25, divide that by 2. 0.625. And so if I add that, that means I'm 0.625. Oh, actually, I should have added these, but it's okay. So I found the difference between 0.65. Add this to 11.25. All right. So add that 11.25. That means that max value is 11.875. All right. Another way, if this confuses you, how I got this number, right? Maybe just add them. Let's add. Let me do that again. That's a mistake. So forget I did that. You actually should have added these two and then found the halfway point. So 12.5 plus 11.25. Divide that by 2. And you get the same answer. You'll get 11.875. That's the halfway distance between them. Okay, so we calculated our max to be at 11.875. Let's do the same process for the min. So look at the graph and find your lowest value. So that's right here. So over here. We need that. Well, if we know that each one of these dashes represents 1.25, so 1.25, again, we're about halfway between 2.5 and 1.25. So halfway between this point right here, the min, and I will do it correctly this time. So add these two to find the halfway point. Divide by 2, and again, I'm going to use my calculator. Clearly, I am making some mistakes. So 1.875. Okay, 1.875. What does the maximum and minimum value represent? Well, we are looking at these values right on the y-axis. So what does the y-axis represent? Well, it represents height in meters. And this whole thing is talking about the height of the water at low tide and high tide. So those heights in meters are talking about high and low tide. So first off, these have both units of meters. Meters. And what this represents, if you think about it in the context, well, the maximum is the height of the water. It's the max height of the water. So this would be high tide. And then the lowest point would be low tide. It's when the water is at its lowest. And that's it. So just kind of putting it to the context of the graph. Determine the period of the function. What does one cycle represent? So remember period, okay? So we are looking for, easiest way to do this is find the distance from max to max, or min to min, all right? These are just the easiest points to find. So the period, if we look at our graph up here, right, it's those square, it's these purple lines I've drawn at the beginning. The distance from peak to peak, right? It's the distance from peak to peak. That's the one I've chosen because it's easy for me to see it. So we can see that we are traveling 2 squares every time we do one cycle. Well, 2 squares is going from here to here. It's going from here to here. So what is the distance of 2 squares? Well, you can see you're going from 0 days to 1 day. So going 2 squares, you have traveled 1 day. So the period is 1 day. Or period equals 1, right? If you actually want to give it a number. And what does one cycle represent? So, think back to my analogy of what I was doing with the breathing, right? Like, if you're, a cycle is like you taking a breath in, breathing out, and then when you go to take your next breath in, that's you starting the cycle again. So if we think about, this graph is measuring high tide and low tide across 7 days. So, in real world, what's going to happen is, the moon is going to come out, and that's going to pull the water. The sun's going to come out, and then that water is going to go back. Moon's going to come out again. Water's going to get pulled. So you're going to have, if you think about your beach, right? You're at high tide. At high tide, you have the water. Let me draw a better beach. It's kind of more slanted like this. So at high tide, you're going to be like way up here, right? And then at low tide, if this is the same beach, your water is going to be like all the way down here. And then when the next day happens, so this happens over 1 day, going from here to here, going from here to here, right, is half a day. Because to get all the way back to a high tide, as we just showed on the graph, to go from high tide to low tide back to high tide, so to go from high tide down to low tide and back up to high tide, you cover 1 day. So what does one complete cycle represent? I ran out of room with my awesome picture I've drawn there. What does one cycle represent? It represents going from high tide to low, back to high tide. Okay? It's just like the breathing. You're breathing in, breathing out. That's one cycle. Breathe in again, start the next cycle. Okay? High tide, low tide, and when you get back to high tide, you have completed the cycle. So determine the amplitude, domain, and range. Ooh, we haven't dealt with these in a while. All right, let's talk about them again. But first, amplitude. So amplitude. Amplitude is the halfway distance, so max minus min, divided by 2, between your max and your min. So we have these values right here. These are our max and our mins. So we'll just put them in. 11.875 was our max. Min was 1.875. Divide these by 2. All right, so I'm going to run out of room. So up on top of our numerator, that would be 10. So actually, A equals 10 over 2. Our amplitude is 5. And again, what are you putting in here? Remember, these units, these max and mins have units of meters. So you're going to have units of meters. There's a 5-meter difference from your axis of symmetry, or your axes, to your max. 5-meter difference from that axis to the bottom. Halfway distance is 5 meters. So the domain and range. Remember, domain talks about all your x values. These are your x's. Range is your y's. So if you were to say your x's, if we look at this graph, we are starting at 0 and we are going all the way to 7 days, right? It's telling you you're graphing it for the first 7 days. So you're saying that your x values, right, the values here, your domain, are that x belongs to real numbers and x is starting at 0 and less than or equal to 7, right? This is 0 days. This is 7 days. It are the x values that you're between. And then range is talking about your y values. What is your biggest and lowest value? So it's talking about like your range, how going from here down to here, this is your range. So in essence, you're saying my lowest value, right, it's your minimum, and then you go less than or equal to y, less than or equal to your max. So if I was to actually write that out, your range would be y belongs to real numbers. Well, we know our min. Our min is 1.875. Less than or equal to y, and we know our max. Our max is 11.875. And there we go. So I remember domain and range. We did that in quadratics, but it's been a bit. So if you need, go back, go look at our lessons. Otherwise, this is our work to be done in class. Okay, so shorter lesson today. I'll see you next time.